All right, welcome to the section 7.3 notes lesson. Section 7.3, I'm sure you will love so much that we'll spend 2 days on it. But first, I want to talk about what we're going to be dealing with for the next 2 days. Just kind of go through what's written here real quick. So suppose we took a right triangle and drew an altitude from the right angle to the hypotenuse. So I've got this right triangle, ABC, or ACB, or whatever. And I'm drawing an altitude. Remember, an altitude is a line from the vertex of a triangle, the vertex of a triangle to the other side such that it forms a perpendicular intersection or forms a right angle. Okay, so this is my altitude H. Turns out when we do that, it breaks it into two smaller triangles. And those two smaller triangles are even more special than just triangles. They're similar triangles. So we have one triangle here, this little one in green. And then let's pick another color here, maybe red. We have another one right here in orange or red or whatever. There's another one. And then we've got one more, and I'll see if I can maybe draw this in. I don't know. How about blue? I've got one more in blue, and that's just the first one that we started with, is this one here. So I've got three triangles that I'm working with. Right there, there's my three triangles. And what's cool is that all three of those triangles are similar. And remember, from geometry A, the similar triangles have all these kinds of properties and relationships among the side lengths. Okay, that's all great, and we can talk about that more, but basically, what we've done for you is we've taken all those relationships and we have turned them into a bunch of formulas. So basically, you need to look at your picture when you get a triangle, like in some of the examples down below. You need to look at that picture and determine what pieces are missing from from these formulas and which formula might help. So let's say you knew maybe you knew A and you knew X. Well, then you would probably be looking at this formula, A equals XC, or the square root of XC, because you know that that would be a relationship that would get you down to one variable. It looks like I'm missing some. This should be A times B here. This should be plus and plus. Sorry, I'm not sure why those are missing. And then, so basically, you need to look at the picture, analyze the figure, and then you need to find which formula is going to work. Okay, so that's the basic idea. One more thing, the altitude here, H, we'll call the height of the big triangle, right? That is the geometric mean of x and y. Remember, the geometric mean is the square root of two numbers multiplied together? Well, H is the geometric mean of x times y. So that is also going to come in handy. So the moral of this part is just basically analyze the diagram, what you're given, and then take that and somehow try and fit a formula to it. Find the correct formula over here in the bank. And then find that missing variable. You may need to use one formula as kind of a helper formula to use another one. So maybe kind of a two-step process, but we're going to handle that on an individual basis. Let's do a couple examples, and then you can try a couple on your own. Okay, so for this first example, we're going to look at it just kind of from a formulaic perspective. We're going to identify what we know in the first triangle, the triangle that we're given, and match that up with what we have in the key triangle, and then match that up with what we have over here in the formula bank. Okay, so let's do that. The first thing I've got over here is I know that x is my altitude, right? That's the line from the big triangle's right angle to the other side at a right angle. So x is my altitude, h. So I'm just going to circle over here everything that I know. I know h. It looks like I know the side opposite the right angle is my c. Okay, so I could figure out c, but I think that it's going to be more helpful if I just know that 5 is my x over here, and y is my 9. And I hope that you can kind of see how that stuff matches up. And we're going to find a formula that relates h, x, and y. So I look over here and it looks like I've got this formula h equals the square root of xy. I think that'll work pretty good. Nothing else down here has an h in it and an xy, so I think that that's definitely what we're going to go for. So let's try it. Let's plug everything in. So I'm going to use this formula, h equals the square root of xy. Okay, well my x, or my h is actually x, right? That's the altitude of the triangle. It's the square root of 5 times 9, right? So that's my 5 and my 9, so 5 times 9. So x equals the square root of 45. And that's it. And then can we simplify that any further? Yeah, I think we can. This is actually x equals 3 times the square root of 5. And that's it. That's the distance x here in the picture. Okay, so in example 2, we're going to look at, we've got another triangle. It's oriented in the same direction, which makes it a little bit easier. And once again, we're going to kind of find out what we know and analyze from there how we can discover that missing side here, A. Okay, so I'm going to look, and once again, I'm going to look at this triangle I'm given and compare it to the triangle up here. I look at the triangle and I see that I've got that I've got A. Well, I look in my triangle up here to the upper right and I've got an A. Okay, that's what I'm looking for. So I know that I'm going to have to look for an equation up here that has an A in it. Next, I'm going to look for an X. I've got a 6 that looks like it fits in the X spot. And then I've got 4 over here, and that looks like it fits in the Y spot. So I'm going to look at any equation that relates A, X, and Y. So I've got A, X, and Y. Okay, so anything that relates those three. And it looks like I've got this one right here. A equals x times x plus y, the square root of that whole thing. So let's try and use that. A equals the square root, right? A is what I'm looking for, of x. Well, x is 6 times x plus y. Well, x plus y is 6 plus 4, right? So this just changes to a equals the square root of 6 times 10. So a equals the square root of 60. And then we should probably simplify that. A equals, and we'll take 60 and we'll break it down. So I'll take a 5 out. So that's going to leave me with 12. Take a 2, that's going to leave me with 6. A 2, leave me with 3, a 3, and I'm down to 1. Okay, if you're a little confused on this part, we can explain it, go over it a little bit more in class, but we should be at a point in your math career where you're simplifying these radicals and not just finding the estimate. So real quick, I'm going to circle my pairs. Right, I've got a pair of 2s, so I'm going to pull that out in front of the square root sign. So those 2's are going to come out front here, so I'm going to have 2 times the square root of whatever's left over, 3 times 5. Okay, so my final answer is a equals 2 times the square root of 15. Okay, so the square root of 60 simplifies too. So once again, check out the drawing, check out the diagram, find the formula. Alright, so that's the process for doing these. What I want you to do now is try number 3 and 4 on your own. Okay, so this video is a little bit shorter because I want you to spend a little bit of time and try 3 and 4. So tomorrow, to get full credit for your notes, you need to bring 1 through 4 completed. I've shown you 1 and 2. You should be able to complete, or at least attempt to complete, number 3 and 4, obviously showing your work in each step that you did. Okay, and that's it for section 7.3. It's a pretty short section, but it's the problems can get kind of complex, so that's why we're going to spend a little bit of time on it, a couple days in fact. So good luck on 3 and 4, and we'll see you in class.